right. This is a brief summary of experiment 2, which you had today. And basically, we've been talking about primary standard and preparation of standard solution. Now, what you're expected to know is the whole of this experiment has to do with primary standards. I've explained that before, what the primary standard is. And the standard solution, you have to know the characteristics of a primary standard and the characteristics of an ideal standard solution. This is what you have to know. And then majorly the calculations. Most of you, I saw a lot of, when I went through your reporting, I saw a lot of mistakes. Somebody would write, let's say he or she got an answer 5 gram. The person would choose to write 5 gram per cm cube. This is wrong. If you want to report molar concentration, or let's say you want to report mass concentration of a particular substance, the unit is in gram per dm cube, all right, or gram per 1000 cm cube. 1 dm cube is 1000 cm cube. So on no account are you supposed to report anything like this. This does not mean molar concentration. This means density. This is the unit for density. This is mass over volume. All right. So in concentration in chemistry, we make use of dm cube. So the standard is dm cube. All right. So that was one observation. And secondly, some of you would go ahead. Let me give an example. Let's say we had let's say calcium sulfate, then let's say 5 molecules of water. It's pentahydrate. This is calcium sulfate. There is a little typographical error in your manual. This is how it should be presented. All right, some of you went to the extent of not knowing how to get the molar mass of such a compound. And now, how do you calculate this? All you have to do is sum all of this. Calcium is 40, sulfur is 32, oxygen is 16. That's 4 multiplied by 16. This dot here means plus, okay? Then we have 10, 5 times 2, 10 hydrogens. So I have 10. Hydrogen is 1. Can you see that? This 5 is applicable to oxygen, so it's going to be 5, open bracket 16. So once you solve the whole of this, that will give you the molar mass, and the unit is gram per mole. Some of you were missing to put this. If you don't put this unit, you're wrong. Okay, let's proceed. Now, using the formula, most of you still found it difficult to actually know how to, make use of the formula. The general formula says molar concentration, which we've been calculating, is equal to mass concentration divided by molar mass. This is what you're expected to know. And these quantities of variables have their units. Molar concentration, right. So the unit is in mole per dm cube, which I said it is equivalent to capital letter M, which is molar concentration. So wherever you see this, it has to do with molar concentration. And mass concentration is in gram per dm cube. So wherever you see this unit, it's talking about the mass concentration, that is mass of 1 mole of that substance in 1 dm cube of the solvent. So molar mass has to do with just 1 mole of that substance, mass of 1 mole of that substance, okay? If, for example, let me make use of this now. If we had 0 sodium hydroxide and the molar mass is 40 gram per mole, molar mass is 40 gram per mole, sodium 23 plus 16 plus 1, 40 gram per mole. So this is mass of 1 mole of sodium hydroxide. All right. So if we had 2 mole, That would be 2 times 40, that would be 80. Okay, so that is what molar mass is all about. So these are the units that helps you to, maneuver any calculation that is given to you. So I will take a little example from your exercise, all right, which you are supposed to have done. Let's take, for example, you were asked to prepare, let's say 1 liter of 0.5 molar, let me say sodium triisocarbonate 4. You see, now you asked, how would you prepare this? How to calculate this is how to prepare it. Basically, your answer, if your answer is, let's say, X gram, it has to bear 1 liter. This is how you're going to present the answer. If you're asked to prepare, let's say, 250 cm cube of the same concentration, this is molar concentration, I said this. This is the volume of what? The same compound, sodium triisocarbonate 4. It means that once you've calculated your answer, and your answer says, let's say, X gram, is going to be in what? 250 cm cube. These are things you are supposed to note. Then you can proceed with doing the calculation. Now let's take, for example, this one. Okay, how would you solve this? Look at these quantities. If you look at this quantity, this is talking about the concentration, because we talked about molar concentration has this unit. So that means molar concentration will be equal to 0.5 molar. And I told you this is the same thing as 0.5 mole per dm cube. So you must not show this, but I'm telling you that this and this are the same. This is telling you that this is 1 mole of that substance, or 0.5 mole of that substance in 1 dm cube. 0.5 mole in 1 dm cube. And 1 dm cube is 1000 cm cube. Okay, now basically what we have is the concentration. Then from this compound, this formula gives you an insight of the molar mass. Okay, that's what we can derive from this formula that has been given for that compound. So we have sodium carbonate as our compound. What do you do? Usually the values could be given, but in a case it's not given, you're expected to know it. Sodium is 23, that's 2 times 23, plus carbon is 12, just one of that. 3 times 16, that's 48. For oxygen is 48. So if you do this correctly, you should be having 106. Now, some of you go to the extent of not even putting a unit. It is wrong. Molar mass has its unit as gram per mole. You have to show that clearly. Every value you are indicating, be sure if it has a unit, indicate it. So you see, we have the concentration, we have the molar mass. This will deal at the letter N, because this is the volume you want to prepare the concentration of sodium triisocarbonate 4. All right, so now you go back to your formula, because basically if you want to prepare this concentration, you have to weigh a quantity of sodium triisocarbonate 4. Now these variables, these values will help you to know how much to weigh. For you to know how much to weigh, you make use of the formula that says molar concentration equals to mass concentration divided by molar mass. Now you see, what you have here is the mass concentration, which is the amount to weigh in order to prepare this concentration in this volume. This is the amount to weigh to prepare this concentration in this volume. So this is mass concentration. We have molar concentration, which is 0.5 molar or 0.5 mole per dm cube. We have the molar mass, which is this. So we just make mass concentration the subject formula. So it's going to be, let me wipe the upper part, okay? So it's going to be mass concentration will be equal to this multiplied by this. That is molar concentration times molar mass. That will be, what was the molar concentration? 0.5 molar times molar mass. We calculated this to be 106 gram per mole. Right? So whatever this gives you, all right, is going to have the unit mass concentration, which is gram per dm cube. Remember that 0.5 molar means 0.5 mole per dm cube. So this could be 0.5 mole per dm cube. Can you see that? So your unit is going to be gram per dm cube. Mole cancel mole, you'll be left with gram and dm cube. Look at it, gram per dm cube. All right. So whatever the answer gives you, I'm not going into that. You can punch that out. That will help you to follow up with this calculation. So let me say it gave you a value which I wrote as x. Okay. Now you ask yourself, this x gram is in 1 dm cube. That is what this means. If you don't write it this way, your answer could be x gram dm cube minus 3. This and this are the same thing. Remember, once you multiply this, the value has to be put here. So what this means is that if you want to interpret this, it means we are going to have this amount in gram dissolved in 1 dm cube. That means you have x gram dissolved in 1 dm cube, right? But look at this, you are working in liters. You are working in liters. Now 1 dm cube is equivalent to 1 liter. Can you see that? Remember, we know what our x is, which is a value which I've not stated, which you will have to punch out. Now you now ask yourself, how much, because we want to know how much we are going to weigh to prepare this concentration in 1 liter. Remember, that was our aim. We don't know how much we are going to weigh. All right, but the amount we got at first was the amount to be weighed in 1000 cm cube, which is 1 dm cube. Now I should have already stopped here because this is 1 liter, this is 1 liter. So that amount, s gram per dm cube, is how much you're going to weigh in 1 dm cube. This is certainly the answer. So whatever you get here is how much you're going to weigh and dissolve in 1000 in 1 liter, which is 1000 cm cube, depending on the standard flask that is provided to you. Now let's take, for example, since you're catching up, let's say here was to be 2 liters, for example. So it means you proceed further, right? The standard is 1 dm cube, 1 liter, or 1000 cm cube. So since you'll be preparing it in 2 liters, you ask yourself, how much? Now, how much is what I don't know, y gram, will be in 2 liters. So I'll come here, I'll put 2 liters. All right? So that means I'm going to multiply 1 by y gram. So it's going to be 1 times y gram, okay, equal to x gram. We know the value, right? X gram multiplied by 2. X gram multiplied by 2. This is what we're interested in. We want to know how much will be in 2 liters. We'll make y gram the subject. So 2 multiplied by whatever value you have here is the answer. And let's say it gave you a value z. So it's going to be z gram per 2 liters, which is a value. This is a value. This is a value you should have gotten from here, right? This is the unknown mass. We want to know how much will be in 2 liters, which is y gram here. So your x gram, which is this is a known value. So you multiply by 2, then you write it this way, per that volume. So this is basically how you get to solve this, all right? So I'm leaving these spaces so that you go through this illustration or this example to find the missing lines and fill it up and get your right answer per 2 liters. So this is how you prepare it. So that means basically you weigh that value here in gram and dissolve it in 2 liters of the solvent. That's the still water. Then you fill it up to the mark. The same thing I've said earlier, 250 cm cube, let's say 0.5 molar. Sodium triisocarbonate 4. All right, so how would you prepare this? Look at the values that have been given. You've been given the concentration, all right, you've been given the volume which you are supposed to prepare this concentration in. This formula alone is telling you this is your what? Your molar mass. This will give you insight to your molar mass. So now look at it. We have molar concentration equal to mass concentration divided by molar mass. What is our aim? We want to know how much we are going to weigh to prepare this concentration in this volume, all right, of this particular substance. That is what this thing means. How much are you going to weigh to prepare this concentration in this volume of this substance? So this formula is giving you insight about the molar mass. That amount you are going to weigh is the mass concentration. Then the molar concentration is given because this is standard solution. Now molar concentration is 0.5, so I have 0.5 will be equal to how much am I going to weigh? And this mole, capital letter M, has to do with dm cube. It means that any calculation you are doing now is in dm cube, and dm cube, 1 dm cube is 1000 cm cube. So now this is 0.5 molar concentration. Mass concentration is what we need to calculate in order to weigh and prepare this volume. So I have divide by molar mass. Once you've done this correctly, I've shown you guys that earlier. 2 times 23 plus 12 plus 3 times 16, 48. If you do this correctly, you should have 106 grams per mole. So this is our molar mass of the substance. So I have 106 here. Now 0.5, right? So I can say this is over 1, x times 1, half x, 0.5 times 10.6, 53 gram per dm cube. Don't miss to always put your unit, it's very important. So this is the mass concentration in 1 dm cube in 1000 cm cube. But the question is, we want to prepare it in 250. This is our aim. But we have to do this first. All right? We have to obey that this is molar and that is mole per dm cube. So we have to go through mole per dm cube, that is 1 dm cube, before we convert to any volume that is being given. So we have, since we have 53 grams per dm cube, all right, let me continue from here. Since we've arrived at the mass concentration to be 53 grams per dm cube, now we can easily calculate. This means I'm weighing 53 grams in 1 dm cube, which is 1000 cm cube. Now you have to look, okay, it is, we are working in cm cube, right? This is not mil. In the lab, I made use of mil because the standard flask that was provided, which we used, had a graduation 500 mil. That was why I made use of mil. But in this case, it's cm cube. All right. So it means, how do you interpret this? You have to interpret this first, then you convert. So this means 53 gram of sodium thiocarbonate 4 in 1 dm cube. This is cm cube, right? And you know 1 dm cube is 1000 cm cube. So I could write 1 dm cube, which is in 1000 cm cube, because we are working in cm cube. So you now ask yourself, since we want to know how much we're going to weigh to prepare this, that's what we want to know. So it's going to, let's call it x, we don't know it. In how much? 250. So I have 250 cm cube. So from here, I'll still do the same thing. 1000 times x is 1000x, right? Then 53 times 250, that will give you around 13,250. So you might not just, indicate the units at this point, but looking at it, if you divide both sides by, once you divide both sides by 1000, it's going to give you the mass, all right, which you are going to dissolve in 250. So if you do this correctly, 13,250 divided by give you around 13.25. So you're going to have 13.25 gram. All right. And if you want to prepare this in 250, this is what it means. That means you are taking this mass, all right, in 250 cm cube. And this is how you prepare it. Okay. This is just simply how you do this. There are other ways of doing it, but this should be understood. And then I want to make a little observation again, just for your clarity, because I needed you guys to always state your unit in the particular volume. All right. If, for example, you want to prepare 2 gram, you got your answer as 2 gram, all right, in a given volume, 250 cm cube. I always want you guys to represent it like this. You can also choose to represent it 2 gram in 250 centimeter cube of solvent. All right, that means 2 gram of what? Sodium carbonate in 250 cm cube of solvent, distilled water. So this is basically how you prepare it. That's what this means. You are weighing 2 grams of sodium thiocarbonate 4. You are dissolving it in a standard flask of 250 cm cube. All right, 250 cm cube, standard flask. Okay, let's say it has a mark, so you have to dissolve this sufficiently. I showed you guys how to prepare it. So after sufficient dissolution, you add distilled water to the mark. Where it reaches the mark for a 250 centimeter cube standard flask, where it reaches the mark, that means you've prepared this concentration. All right, so this is basically all you have to know about experiment 2. In summary, mass concentration gram per dm cube, molar concentration mol per dm cube, which is equivalent to molar. Then we have the molar mass, which is gram per mole. So you have to know these units and what they stand for. All right, so see you guys in the next experiment.